225 with Professor Wise. In this video, we're going to cover the basic principles of the water hammer effect, the siphon, and Bernoulli's equation. Bernoulli's equation is an incompressible fluid is moving through a closed pipe system. The size of the pipe changes the velocity and pressure within that system. In layman's terms, Bernoulli's equation says that the speed of the fluid increases, the pressure within that system decreases, or vice versa. The water hammer phenomenon that causes a pipe to shake violently when the valve is closed suddenly. A water hammer is when the flow or fluid, usually water, is stopped rapidly, causing a surge or wave within the system. We all have had, at one point or another, experienced a sound or shaking of a pipe. The water has been turned off rapidly and causing the water hammer effect, which is the clinking noise of the pipe you would hear. Think about a time you've heard a pipe shake. Most likely occurred in an older home or building, or even when filling up a drink from a soda fountain when you hear the valve close rapidly. The water hammer effect can be prevented using an arrestor or a thrust block. Water hammers and siphons do not need the assistance of electricity, as both can be fully mechanical systems.
Here we have a water hammer example. The water has been shut off. The water that was rushing through it is now collapsing back against the valve, and you can see it right here as it just snaps against the valve. This is really bad for pipes. You can see the displacement that it's shaking this example. The consequences, pretty rough, okay? As you can see, it progresses here. In the top right hand corner, you're going to see the pipe yields, or the seal yields at least, and water is escaping. In the second example, we're going to see how the forces translate onto a graph. As you can see, the water valve is opening up right now. Water is flowing through it. Okay, the valve is clanking against the top, which is also not good for the pipe. But as that valve closes, you're going to see the water snap back. It's going to vibrate. It's going to shake violently. You can see in the graph that it's not good. Looks like the Appalachian Mountains right there. It's not what you want. But thankfully, there's many things you can do to prevent this, and that's what we're about to get into right about now. We're going to talk about water arresters now, okay? So buckle up. Basically, you take a water arrestor and you place it on top of your pipe near or around your shut-off valve. And when you shut off this valve, the water momentum, the water hammer, will flow up into the arrestor. The water momentum will push on the sliding piston onto the air chamber, and that will act like a shock absorber, like the shocks in your car. Okay? And off to the right here, you can see that there's many different sizes. Some say size matter. I say it depends on the job. And of course, the arrestor shown here is the newer style arrestor. Back in the older days, the arrestors were just filled with air. They lacked a sliding piston. And what that meant for homeowners or people who needed water arresters is that the air would still act as like a cushion, but only for a certain period of time. Eventually water would leak in there, and then it would be filled to the brim, thus leaving the water arrestor useless, and the water hammer would still wreak havoc on your pipes. So the way that you would have to fix that was to clear your pipes entirely every once in a while after an extended period of time, clear out the water arrestor, and then fill the pipes back up, and then you would have a pocket of air in the arrestor again, which the process would start over.
It is noted that in Ohio Building Code 1206.7, requires the water hammer effect to be controlled where quick closing valves are present. An arrestor must be placed within a specified range of the manufacturer of the quick closing valve. Some examples of this are either in your dishwasher or washing machine.
This brings us to thrust blocks. Basically, thrust blocks are um, dams of concrete or a sturdy material that prevents damage to the pipe caused by unsupported pipe movement. Basically, what that means is when you get water hammer or other phenomena like that, the shaking of the and the rattling of the pipe can damage the pipe, cause cracks, cause strains. Um, and what you do, as you can see in this diagram, is you just put concrete in the flow of the water, and you anchor it down. You need a control point to keep that pipe from rattling. And it's a pretty simple concept, but it's super useful. Like people still use this all the time. Thrust blocks are used in all walks of life. You know, you got it in your residential facets, commercial, heavy industrial, and a lot of times, you know, your road work, your sewer work, your infrastructure. That's where you'll find thrust blocks most used.
Siphons have been used for thousands of years, dating back to the ancient Egyptians in 1500 BC, in order to extract liquids from large storage containers. This was used because they needed to change the liquid from one storage container to another or take it out of the container itself. Siphons are used to move liquids from one point to another without the use of a pump. Siphons will continuously operate once they are started until the pressure changes or allows air in the system, or the liquid being siphoned runs below the intake level.
Here we have a real example of what we have explained. We have a water tank on the right. The ram pumps using the potential energy of the flowing water to pump the water to a higher elevation. 100% efficiency, that means the water flow 10 liters per second at 10 meters drop. With the 100 meter of water head, the potential energy for both is equal 1 joule. So here the water flowing from a higher elevation into the pipe. The water flow with a high speed in which it causes to close the waste valve. When it closes, the water flow to the other side. Here we have a real example of what we have explained.
Alright, here's a backyard example of a ram pump, as they call it, or a water hammer pump. Um, Basically, he's got water rushing in from the right side of that PVC, and it rushes across the bottom into that waste valve right there. And once it reaches a certain flow rate, the valve closes. It smashes shut. The water will have a hammering effect. It'll go up into the arrestor and be pushed into the yellow hose, and the hose will take it to wherever it needs to go. In this case, on top of this guy's roof. I think he's just showing this as a demonstration. We can take a look at this one more time. Basically, a ram pump is used to get water in a very low-tech way into a higher position. If you're taking a look at this diagram, it flows from the tank number 3 down the inlet pipe number 2 into 5, the hydrant body. Once it reaches a certain flow rate, number 1, the waste valve will slam shut. The water will hammer. It will go up past number 6, which is the delivery valve, into number 7, the air chamber, which will push back, then pushing it up into number 8, which is the delivery pipe. And that is the gist of a ram pump. You'll mostly find these in farms. Like all good things, they must come to an end. This has been the Water Hammer and Siphon video by Brandon, Ravine, Hamund, And Kyle Persiak, that's right. Signing off. Au revoir. Salut. Aloha.